Hello and welcome back. In this video, we want to solve for the integrals of this function. But look at the nature of this problem. We have that the integral I is having this triple integral from 2 to 5, 1 to 3, and then 1 to 2, which is upper and lower limits integrations of this function 2x minus y plus 2z with respect to x, y, and z. So what we need to do at this point quickly is to take the integral from 1 to 2 of this function with respect to x firstly, then after which we do for the second and the third, and that will finish the process in 1 second. So if you're just watching this video for the first time, please hit the subscribe button right now, like this video please, and also share this video when necessary, because people also need to watch alongside with you. Alright, so let's start solving right away. It is given that I is equal to the integral from 2 to 5, integral from 1 to 3, integral from 1 to 2 of the function 2x minus y plus 2z with respect to x, y, and z. So the best way we can follow up this problem is to take the integral from 1 to 2 of this function 2x minus y plus 2z, and then that's with respect to x, and the result to this will be when you integrate 2x squared, you have 2x raised to the power of 1 plus 1, because the power we have here is 1, so add it with 1 using the formula of integration that says x to the power of n plus 1 over n plus 1 plus constant c. Hope you still remember. So the n is for the power we have here, which is 1. If you add up to this one, you have it here, all over 1 plus 1. Alright, so that's what you essentially do here. Okay, minus, here does not have a term of x because we are differentiating with respect to x and we're having just y here. So what you need to do is just to add the term of x to it. Similarly, for z, we are not differentiating with respect to z, neither y. It's with respect to x, which is why you see us integrating. We are not integrating with respect to y and z. It's only with respect to x. So at that point, for this, we'll also write 2z and add the term of x to it. Alright, and keep in mind that we have, you just draw a line like this because we have the upper limit of 2 and lower limit of 1 attached to the problem. So the next phase is to make this look normal. Of course, 2x to the power of 1 plus 1, 1 plus 1 is 2, 1 plus 1 is 2. 2 will eliminate these 2. What we have is x squared minus yx plus 2zx, and we have 1 to 2. Alright, so what's the next phase? Because we have upper and lower limits, we need to substitute 2 into this function, and after which we substitute 1. So there we have 2 squared minus, if you put in 2 here, times y will be 2y. Alright, plus, if you multiply 2 by this 2, because you plot in 2 here, that means 2 times 2 will give us 4. 4 times z will give us 4z. Right, so you could just put this in a bracket because we need to subtract it from when you plot in 1. So let's plug in 1. We have 1 squared minus y, because 1 here times y is y, and then here if you plot in 1 here, 2 times z, we have plus 2z. Alright, so this is what we have. So what's the final expression here? We know that 2 squared will be 4, and then we have here to be 4 minus 2y plus here will be 4z minus, we affect this, 1 squared is 1, minus 1 plus, minus is plus, y minus plus is minus, they have 2z. So the final point of this will be 4 minus 1, collecting like terms, that will be 3, and then minus 2y plus y, that will give minus y. And then the last one is 4z minus 2z. It will give us plus 2z. So this is the solution for the integral of 2x minus y plus 2z dx with from 1 to 2. Okay, so now we are done with that first one. The second one, we have the integral from 1 to 3 of this function with respect to y. And then the function is not this again, is this last one we got. So this is how it's going to be. We have the integral from 1 to 3 of this function, 3 minus y plus 2z. It's no longer going to be the initial function with respect to y. So let's do this quickly. Now we've gotten the idea on how we can go about it. So let's just plug in the value. If you integrate this 3, then you have y attached to it, because if you integrate 3 with respect to y, or any constant with respect to the variable attached, then you just have that constant and that variable. So here, integrating 3 with respect to y, we just give 3y, minus integrating y, you have 1 here, so it means we have y squared all over 2, because we add 1 plus 1, that will be 2 divided by 1 plus 1 using that formula of integration. So we have plus, here does not have a term of y, so we just add y to it. So we have 2, we're supposed to have 2zy, but y comes before z alphabetically, so we just leave it like this. And then we have the upper limit of 3 and lower limit of 1. Okay, so the next phase is to substitute the upper limit of 3 first. So we have 3 multiplies by 3, all right, into minus 3 squared over 2 plus 2 multiplied by 3, then z. Let's have this in the bracket, minus, we need to also substitute this 1 into 3. So I have 3 into 1 minus 1 squared over 2 plus, if you plug in 1 here, we have 2 times 1, which is 2. Let's just make it there for clarity. So what's the next step? We know that 3 times 9 is 27, minus, here we have 9 over 2, and then we have here to be 6z, minus 3 by 1 is 3, minus, we influence this one to have it plus, 1 squared is 1, so we have 1 over 2, then minus, we influence this to be minus, 2 times 1 is 2, and times z is 2z. Alright, so with this we can collect terms. How do we intend to do that? We have 27 minus 3. By the way, we have an omission here, because by the time we bring in this 3 to replace this, we have here to be 3 and not 9. I was multiplying it through and forgotten that I have 3 here already. So let's do that correction quickly. So 3 times 3 will be 9. Right, that's a slip of thought. So we have here to be 9. So that balances the problem. So what's the next thing we need to do? By the time you have 9 minus 3, you should be having 6. So if you have 6 at that point, then you have minus 9 over 2 plus 1 over 2. Then we have the next one to be 6z minus 2z. That will give us plus 4z. So let's play with this fraction quickly and then use the answer across the system. So we have here to be, the LCM is just 2. 2 into 2 is 1, times 9 is 9, plus 2 into 2 is 1, times this is 1. So plus 4z. This will eventually give us 6 minus, and here we have 10 over 2 plus 4z, and 10 divided by 2, that will be 5. So 6 minus 5 is 1 plus 4z. So this is what we have as our answer for the second integral. So let's look forward to the third integral. So the last phase will be the integral of let's look to the problem. Okay, the integral from 2 to 5. So we have here to be the integral from 2 to 5 of this function, which is 1 plus 4z, and this will be with respect to z. Alright, so the integral of 1 with respect to z is simply z, plus the integral of 4z will be just 4z to the power of 1 plus 1 all over 1 plus 1. Alright, since it is upper and lower limit, we don't really need the plus constant c. So what we need to do is just to have from 2 to 5 here. So then z plus 4z to the power of 2 over 2, and here is from 5 or 2 to 5. Then the next point is to say z plus this 2 going into itself is 1 into here is 2, so we have 2z squared from 2 to 5. So let's plug in 5 into the system. So we have 5 plus 2 into 5 all squared, and this will subtract, plugging in 2, we have 2 plus 2 into 2 all squared. So this becomes 5 plus 5 squared is 25, and 2 times 25 is 50, minus 2 plus, okay, minus influencing this influencing this plus will be minus. So 2 squared is 4, 2 times 4 is 8. So here we have 5 plus 50 is 55, and then minus 2 minus 8, that will give us minus 10. So if we add up this, the result to this will be 45. Alright, so therefore the entire problem, which is integral from 2 to 5, integral from 1 to 3, integral from 1 to 2 of this function 2x minus y plus 2z with respect to x, y, and z is equal to 45. Thank you very much for watching, and please hit the subscribe button, turn on the notification bell so that when I upload new video you get notified, and please like this video and share. Drop a nice comment if you enjoyed this video. Bye.